MS Ramaya University of Applied Sciences.
Hello friends, with this experiment we are determining the flexural strength of concrete beam. Apparatus: beam mold, iron pan to mix concrete, weighing balance, trowels, measuring jar, tamping rod of 16 mm diameter and 0.6 meter long with bullet point at the lower end, universal testing machine UTM. Concrete, as we know, is relatively strong in compression and weak in tension. In reinforced concrete members, little dependence is placed on the tensile strength of concrete since steel reinforming bars are provided to resist all tensile forces. However, tensile stresses are likely to develop in concrete due to drying shrinkage, rusting of steel reinforcement, temperature gradients, and many other reasons. Procedure: calculate the required quantity of materials and weigh the required quantity of materials, that is, cement, sand, fine aggregate, coarse aggregate, and water. Mix the dry constituents thoroughly to get a uniform color. Clean the beam molds and oil it completely. Then add water to the dry mix and mix it completely to get a uniform color. Pour the concrete into the beam molds in 2 layers and tamping each layer by 35 times using tamping rod. Struck off the concrete on the top of the mold. After casting, keep the beam molds for air drying for about 24 hours. Then remove the concrete beams from the molds and keep it for curing about 28 days. The specimens are tested for required number of period for 28 days. Data collection and tabulation is as shown. Data collection and tabulation is as shown. Data collection and tabulation is as shown. F is equal to PL by AD square when A is greater than 20 cm for 15 cm specimen or greater than 13.3 cm for a 10 cm specimen, or F is equal to 3PA divided by BD square when A is less than 20 cm but greater than 17 cm for 15 cm specimen, or less than 13.3 cm but greater than 11 cm for a 10 cm specimen.
Hi students, we are conducting the second experiment, that is the flexural strength of the concrete in hardened concrete experiment. So the apparatus required for this particular test is the flexural testing machine. Okay, so this is a flexural testing loading frame. This is a control unit. It's an old type, the dial gauge type of system. Okay, so we want a mold. If you are using a concrete mix which is having less than 20 mm down aggregates, we are going to make use of this type of mold which is having 10 cm width, 10 cm depth and 50 cm in length, that is 10 by 10 by 50. If the aggregate is more than the prescribed, then we are going to go for 15 cm in width, 15 cm in depth and 75 cm in length. These are the two standard molds which we are going to use for doing the flexural test. Apart from this, we require the materials like cement, fine aggregate and coarse aggregate should be proportioned as per the design. We are going to mix that particular mixes. We are going to prepare the concrete and we are going to put it on this mold. The second step is preparation of mix. As of now, we taken 2.5 kgs of cement, 5 kgs of fine aggregate and 7.5 kgs of coarse aggregate, which comes to ratio 1:2, 2:3. We generally do it for M20 grade concrete. For the first trial, I am considering the water cement ratio as 0.4. We start mixing the concrete. First, what we are going to do is we make sure that the concrete mixer is on the inner side, it is smeared with the oil. So first what we'll do is we add the coarse aggregate. So we are going to add the coarse aggregate to the concrete mixer. After coarse aggregate, the fine aggregate will be added. After this, the cement will be added along with the water which is prescribed for this particular mix. Add the water. We are pouring the entire mix of concrete onto the tray. After preparing the mix of concrete for flexural strength, what we are going to do is we are going to smear the oil inside the flexural mold. We are going to put the concrete in 1/3 layer. So after 1/3 layer, I can do with the tamping, compaction by tamping, by 25 number of blows to the first third layer, 1/3 layer, or I simply on the vibrator. I am going to add the second third layer. At last, I am going to add the final layer and finish the surface. ಇಟ್ಕೊಬೇಡ ಬಿಟ್ಬಿಡು ಅದು ತುಂಬ ಸ್ಲರಿ ತುಂಬ ಎದುರಳತ್ತು. I am going to finish the surface using the trowel. So this prepared mold is kept as it is for 24 hours. It's demolded. Then the demolded sample is kept in curing tank for 28 days to know the flexural strength of 28 days. After preparing the mix for flexural strength, we are going to catch the mold, keep it in air for 24 hours, demold it. Then the mold of flexural strength or the prism, we are going to keep it in curing in water for 28 days. After 28 days of curing, whatever the sample we are going to get is of this type. Okay, so it's going to have a length of 50 centimeter, the width will be 10 and the breadth will be 10 centimeter. What we are going to do is we are going to subject this for 3-point loading. So what I am going to do right now is I am going to mark the effective length. What is meant by effective length? The gap between this particular roller to the other roller, we call it as a effective length. This is 40 centimeter. So what I'm going to do, I'm going to do a marking on this prism for 5 centimeter. Approximately here, using a scale, I'm going to do the marking, do the 5 centimeter marking. We are placing this sample on the flexural test setup. We are making sure that these markings are exactly in line with the rollers. We down this load setup and make sure that the top two rollers is touching the beam. So this is the beauty of this particular experiment. The entire length of this sample is divided into 3 halves. That is the first portion, the middle third and the final third. That's why it's called as a 3-point testing. After doing this initial setup, what we are going to do is, we come to the operating end, we close the we lock the hydraulic thing. It's a dial gauge where we are having each division represents 0.5 kilonewton. Okay, and what we are going to do, we are going to start the experiment. Please observe the loads over there. So we are applying the load on the flexural specimen. At one particular thing, a central crack is going to arise and the specimen is going to fail. So you observe, you stop the machine and note on you observe at the center there will be a formation of crack. At the end there will be the formation of crack. Note on the value of reading on the dial gauge. This is what we call it as a P. Okay, use of formula, FCR is given by PL by BD square. Okay, so when to use the formula is, if your crack is between 1/3 to 2/3, we are going to take up the effective length. If the crack is at the supports, that is within 1/3 or more than 2/3, we are going to take up the total length. Let us observe where the crack it is. But this particular point, what we are going to do is, we just note down P value, that is the load of failure. I am releasing this. I am taking out the sample. So you observe that this particular crack is in between 1/3 and 2/3. So we are going to make use of the formula PL by BD square, where L is the effective length. Okay, same way you are supposed to do the testing for 3 or 6 samples. So the average of the result will be taken and it will be represented as the flexural strength of the concrete, that is FCR. This FCR will be very useful when you are designing the rigid pavement. If you refer IRC 58 for designing the rigid pavements, this FCR values plays a vital role. This completes the flexural strength experiment.
At MSR UAS, we spark your imagination unlike any other.